What if the oldest stories about a place turned out to be pointing at something real? For generations, native elders have spoken about what lies beneath the Grand Canyon, not just metaphorically, not just spiritually, but as a genuine warning about forces and spaces hidden deep inside that stone. Scientists, geologists, and archaeologists have spent decades peering into those same walls, with increasingly powerful tools. And what they found raises questions that neither side can fully answer alone. Here's what this video actually is. It's an honest comparison of oral tradition, documented geology, verified archaeology, and the popular claims that fall somewhere in between. Some of what you're about to hear is supported by hard evidence. Some of it remains genuinely unresolved. Some of it is disputed, and we'll be clear about which is which. Before we go deeper, hit subscribe and drop a like. Content like this takes real research, and the algorithm doesn't always reward that. Your support keeps it coming. Now, 1 mile deep, 277 miles long, nearly 2 billion years of exposed rock. The Grand Canyon doesn't just show you the surface of the earth. It shows you what's underneath everything. So what exactly is down there? To understand why this place generates so much serious inquiry and so much wild speculation, you have to understand what the Grand Canyon actually is. Not the postcard version, not the tourism brochure. The real thing. The canyon is essentially a wound in the earth that refused to heal. The Colorado River has been cutting downward through layers of rock for somewhere between 5 and 6 million years, and as it carved, it exposed something that geologists consider almost impossibly rare, a continuous readable record of approximately 2 billion years of Earth's history, all stacked in a single vertical slice. To give you a sense of what that number means, 2 billion years ago there was no complex life on this planet. No fish, no forests, no insects. Single-celled organisms were the whole story. And the rocks at the bottom of that canyon date to that world. Most places on Earth, that ancient rock is buried, covered by younger sediment, folded by tectonics, worn down by glaciers, hidden under cities and oceans and soil. The Grand Canyon is one of the few places where erosion worked so aggressively and where the underlying geology was so stable that all those layers remained more or less intact while the river cut straight through them. You can hike from the rim to the river and walk backward through nearly half the age of the planet. That's not a metaphor. That's what the rock record actually shows. Now, here's where it gets interesting. The walls of the canyon tell you one story. What lies below the visible surface tells you another. Because the canyon is not just a cross-section of history. It's also a structure full of hidden architecture, fractures and fault lines that don't appear on the surface, cave systems that branch off behind the canyon walls into darkness that no one has fully mapped, aquifers that move water through porous rock at depths that can take thousands of years to traverse, springs that emerge miles from where the water entered the ground, having traveled through pathways that no instrument has ever directly observed. The canyon shows you what it wants to show you. Below that, things get considerably more uncertain. And that uncertainty is not just a scientific problem. It's a cultural one too, because for thousands of years before any geologist set foot near the rim, the Grand Canyon was not a geological curiosity. It was home. The Havasupai have lived within the canyon itself for centuries. The Hopi, the Navajo, the Zuni, the Southern Paiute, the Hualapai, multiple distinct nations with distinct languages, distinct histories, and distinct relationships to this landscape. For these peoples, the canyon is not a static formation to be studied from a safe distance. It is a living geography embedded in cosmology, in ceremony, in practical daily knowledge accumulated across generations. The canyon floor, the springs, the caves, the trails, all of it is woven into cultural memory in ways that Western science is only beginning to take seriously as a distinct and legitimate form of knowledge. The difference between these two approaches used to be framed as a conflict. Science versus tradition, evidence versus belief. That framing was always too simple. And increasingly, researchers in geology, hydrology, and archaeology are finding that oral traditions sometimes encode observational data that turns out to be accurate in ways that demand explanation. We'll get into specific examples of that later in this video. For now, the point is that the Grand Canyon is simultaneously a geological archive and a cultural archive. and both of those archives are only partially open. So why does this place inspire both rigorous science and enduring mystery? Part of the answer is scale. The canyon covers more than 1 million acres. It has over 600 known caves. The majority of them have never been professionally surveyed. The underground water systems beneath the canyon are connected to springs and aquifers across a region spanning thousands of square miles, and the exact pathways of that water remain poorly understood. The sheer physical scale of the place means that genuine unknowns are not manufactured for dramatic effect. They are a straightforward consequence of how much canyon there is and how difficult it is to access. But the mystery has another engine, and that's the gap between what is visible and what is implied. When you stand on the south rim and look down into that canyon, you're seeing the exposed faces of rock layers. You're not seeing what's behind them. Caves in limestone form when water dissolves rock from the inside, leaving voids that may never reach the surface or appear on any map. The Redwall limestone formation that runs through the canyon is a particularly productive environment for cave development, and it runs through hundreds of miles of canyon walls. What's inside those walls nobody fully knows. That combination, the visible grandeur and the invisible interior, creates an almost irresistible invitation to speculate about what might be down there. Some of that speculation is grounded in genuine geological possibility. Some of it is shaped by a contested 1909 newspaper story involving Egyptian artifacts and secret Smithsonian expeditions that has taken on a life of its own across the internet and alternative history communities. Some of it emerges from tribal oral traditions that describe chambers, passages, and underground worlds beneath the canyon in terms that can be read as literal or symbolic or both, depending on who you ask and what framework you're applying. We're going to walk through all of it, carefully, without dismissing any of it before we've looked at the evidence. This video is specifically about 5 things: the geology of the canyon and what it tells us about what might lie below the visible surface, the cave systems and underground water that have been documented, and the ones that haven't, the oral traditions of the canyon's native peoples, and what their warnings and stories actually say when you examine them on their own terms, the archaeological record of what has genuinely been found inside the canyon, which is extensive and remarkable on its own without any embellishment, and the contested claims, the popular stories, the government conspiracy narratives, the alternative archaeology, examined against what the evidence actually shows. We're not here to tell you the canyon is hiding a lost civilization. We're also not here to tell you that everything is fully understood and anyone who finds this place mysterious is being irrational. Both of those positions are lazy. The canyon is genuinely extraordinary, the unknowns are genuinely real, and the intersection between scientific investigation and indigenous knowledge is genuinely more complicated and more interesting than either camp usually acknowledges. What the elders warned about is worth taking seriously. What the geologists found when they looked inside is worth understanding in detail. What the archaeological record shows, and what it pointedly does not show, matters for evaluating the popular claims. And the actual geology of what might exist in the spaces no one has mapped yet is a legitimate scientific question with a more interesting answer than you might expect. 1 mile deep, 2 billion years of stone, hundreds of caves, systems of water moving through rock in near total darkness, oral traditions stretching back further than any written record in the region, and a set of questions that science has answered in part, but only in part. That's the archive. Now let's go through it layer by layer. When people online say the elders warned us about what's under the Grand Canyon, it usually gets boiled down to one dramatic sentence. Secret tunnels, forbidden caverns, things man was not meant to see. The reality is messier, older, and in many ways more grounded. Across the region, different native nations have their own languages, ceremonies, and religious systems, and that means they have different stories about this landscape. Hopi traditions, Navajo traditions, Havasupai traditions, Zuni traditions, Southern Paiute traditions, Hualapai traditions, they're not interchangeable. They don't form one single native belief about the canyon. They're more like parallel archives, each organized around its own sacred sites, origin points, and responsibilities. What they tend to have in common is this: knowledge of places preserved and transmitted through oral tradition, and that tradition is not casual storytelling. It's a system. In many of these communities, stories are not just entertainment around a fire. Their instructions, warnings, maps, and ethical guidelines, all wrapped in narrative. A story tells you when it's appropriate to be in a certain place, what to do when you get there, what you must bring, what you must never bring, and who has the right to lead the way. It transmits information about water sources, animal behavior, weather patterns, and hazards, but it does so in a way that keeps that knowledge anchored to social and spiritual responsibilities. When elders talk about certain caves or side canyons as dangerous or not for everyone, you can't separate that warning from the larger framework it lives inside. Sometimes the danger is framed in spiritual terms: powerful beings, emergence points, entrances to other worlds, places where ceremonies took place and should not be disturbed. Sometimes it's about protocol. Only specific clans, lineages, or ceremonial practitioners are supposed to go there, or only at certain times for specific reasons. And sometimes, layered under the cosmology, there is very practical terrain knowledge: loose rock, sheer drop-offs, unstable slopes, flash flood paths, oxygen-poor chambers, and water that can be scarce when you most need it. In oral tradition, these aren't separate categories. If a place is spiritually powerful and restricted, part of what that power means is pay attention. Don't wander in uninvited. Don't treat it like a hiking challenge. That's a fundamentally different mindset from an outside explorer with a GPS and a YouTube channel looking for secret spots. Outsiders encountering these stories have often done something very predictable. They lifted parts of the narrative out of context, flattened them into something they already understood, and then repackaged them for their own purposes. A story about an emergence point, a place where people came up from a previous world, becomes, in a treasure hunter's imagination, an access shaft to a literal underground city. A taboo on entering a cavern without the right ceremony becomes evidence that there must be something physically hidden in there that powerful people don't want you to see. In other words, symbolic, spiritual, and social warnings have been repeatedly reinterpreted as literal treasure maps. You can see why this happens. If you already believe there's a lost civilization buried in the canyon, and you hear an elder talk about an underground world connected to this one, it's tempting to say, aha, they're talking about the same thing I'm looking for. But that move skips past the actual meaning those stories have within the communities that tell them. It treats them as coded hints in somebody else's adventure narrative, instead of as complete systems of knowledge in their own right. At the same time, it would be a mistake to swing to the opposite extreme and say, it's all just metaphor, nothing to do with physical reality. When elders say a particular side canyon is alive or listening or not a place for children, that may express cosmology, but it often tracks with very practical observations gathered over generations. If your community has watched rockfalls cascade from a particular cliff after freeze-thaw cycles, if your grandparents saw a flash flood rip through a narrow slot with no warning, if a pocket of bad air in a sinkhole made someone dizzy, if an apparently solid ledge collapsed under a sheep or a person, you don't necessarily build a spreadsheet of incident reports. You build a story. That story might involve spirits, or underground beings, or consequences for disrespect. But at ground level, it also functions as a durable warning label. This place demands caution. The key is that access is often not simply allowed or forbidden, it's conditional. Certain individuals, at certain times with certain preparations, may go to a place that others are explicitly told to avoid. That's not secrecy for its own sake. It's a way of handling risk, spiritual and physical, while preserving relationships to powerful sites. From the outside, when you're not in the network of kinship, ceremony, and obligation that orients those rules, all you might hear is, the elders say don't go in there. If you arrive already primed to suspect cover-ups, that line sounds like a clue that something huge is being hidden. In reality, it may mean something closer to, this cave ceiling has killed people, this spring is fragile and easily contaminated, these petroglyphs mark a burial area, or this is an origin place whose disturbance would be a violation, not an adventure. Different communities place the emphasis differently. Some traditions focus strongly on emergence and underworld journeys, layered worlds stacked beneath the surface, connected by openings that can be physical features in the landscape. Others emphasize ancestral footprints, migration routes, and shrines located at very specific points along the canyon walls or on the plateau. In all of them, though, the canyon and its hidden spaces are not empty. They're inhabited by history, by beings, by obligations. That's why, when elders issue warnings about what lies beneath, they're rarely talking about monsters in the cave in the way a movie might frame it. They're talking about relationships and boundaries. There are places where you announce yourself, places where you offer something before you take water, places where you don't speak certain names, places where you simply do not go, not because a ranger posted a sign, but because your grandparents and great-grandparents passed down clear instructions not to cross that threshold. So when the internet compresses all of that into "tribes say there are forbidden tunnels under the Grand Canyon," it loses the core of what's actually being said. The warnings are less about feeding a mystery plot and more about sustaining a long-term relationship with a powerful, dangerous, and life-giving landscape. They blend cosmology with careful observation of cliffs, currents, sinkholes, and storms. Which raises a harder question. If these oral traditions encode both spiritual meaning and practical hazard, what happens when they intersect with modern science, land management, and public curiosity about who the canyon belongs to? That's where we have to look at whose stories get centered when we talk about this place and whose protocols get ignored. When you look at a park map or a geology diagram of the Grand Canyon, it can feel like a neutral shared backdrop. Layers, rivers, overlooks, but on the ground, this is not just public land. It's a dense overlap of homelands, origin places, and ongoing jurisdictional fights. If you zoom out from the canyon itself and look at the whole region, you're inside a network of native nations that have been here for a very long time. The Havasupai, whose name literally means people of the blue-green water, living in a side canyon where those turquoise waterfalls feed their fields. The Hualapai, stretching along a huge section of the canyon's western rim. The Hopi, whose mesas sit to the east, with traditions that tie their people's emergence and migrations to specific features in and around the canyon. Navajo, or Diné, surrounding much of the region, with stories and sacred mountains that frame the whole landscape. Southern Paiute communities to the north and west. Zuni to the east, with migration routes and shrines that reach into this territory. Each of these nations has its own language, ceremonial cycle, and history with the canyon. They don't all agree on where key events happened, which beings live where, or how particular cliffs and springs should be approached. That diversity is the point. Tribal perspective is not one file you can open and quote from. It's many separate archives that sometimes intersect and sometimes don't. Take the idea of emergence, for example. In some Hopi accounts, people came up into this world through a sipapu, an emergence point associated with the Grand Canyon region and the nearby Little Colorado River. That doesn't mean every Hopi person today points to the exact same rock and says there. It also doesn't mean the Navajo, the Hualapai, or the Havasupai tell that event in the same way. Different nations can share broad themes: worlds beneath, journeys upward, migrations across the plateau, without collapsing into one shared storyline. At the same time, some physical places sit at the crossroads of multiple traditions. A spring might be a ceremonial site for one community, a boundary marker for another, and a danger zone for a third. That spring is not just a dot of blue on a hydrology map. It's part of a sacred geography, a network of points that only really makes sense when you've grown up inside the stories that connect them. That's where the idea of off-limits places gets complicated. To a tourist or a YouTube explorer, off-limits sounds like a challenge, a place the government or they don't want you to see. But in these indigenous geographies, limited access is often about responsibilities, not secrets. Some caves are burial sites. Some alcoves are where specific ceremonies happened and are still considered alive with that power. Some ledges are shrines tied to clan histories or migration stops. That can mean only a particular clan goes there, or only a set of ritual specialists, or only at certain points in the ceremonial calendar. If you're not part of that circle, the answer isn't sure if you sign a waiver. The answer is no. This is not your place to enter, and that no can carry multiple layers at once. On the surface, respect the dead, don't disturb ceremonial grounds. Underneath that, these locations are physically fragile. A single careless footstep can damage a petroglyph, collapse a ledge, or contaminate a tiny water source that a community has relied on in drought years. Oral histories wrap those layers together, so that the ethical rule and the ecological rule are the same thing. This is one of the reasons those stories are so dense. A migration narrative might tell you how ancestors moved across the land. It might also quietly encode where water can be found in different seasons, which plants grow in which soils, what animals appear before certain storms, and which canyons have a history of rockfall or flash floods. A moral teaching about arrogance or disrespect might, at the same time, be a cautionary tale about walking alone into a narrow side canyon when clouds are building 20 miles away. From the inside, that integration makes sense. You don't separate cosmology, ecology, and ethics. You inherit them as one package. From the outside, people hear one line about underground worlds or dangerous caves and pull it out of that system. That's where a lot of internet myth-making starts. Someone hears that Hopi talk about multiple worlds below this one, or that Zuni or Paiute stories mention beings in the depths of the earth, or that Havasupai elders warn against entering certain chasms. Online, that becomes proof of literal lost cities, reptilian dwellers, or ancient artificial tunnels. The original context, ceremonial obligations, migration memory, practical hazard, gets stripped away and replaced with a plot that fits a pre-existing fascination with hidden civilizations. There's another problem. Online, native elders are often quoted without any source at all. A random forum post or fringe documentary will say, "The tribes say," and then launch into a story that doesn't match any documented tradition from Havasupai, Hualapai, Hopi, Navajo, Paiute, or Zuni sources. In some cases, you can trace those claims back, not to actual community knowledge, but to early 20th century writers, spiritualist movements, or outright fiction. Distinguishing between those things matters. There are recorded songs, prayers, and oral histories that have been shared publicly by cultural authorities, sometimes in collaboration with archaeologists, anthropologists, or park staff. There are also restricted teachings that are not meant for broad circulation and don't belong in a YouTube breakdown at all. And then there's a third category, outsider inventions, later layered on top, and then mislabeled as tribal legend to give them more weight. Responsible storytelling about the Grand Canyon has to keep those categories separate. That means being clear when we're talking about documented traditions that communities themselves have chosen to share, versus later interpretations, versus pure internet speculation. It also means acknowledging that different native nations sometimes interpret the same cliff, spring, or cave in different ways, and that none of those readings exists simply to serve an outsider's mystery narrative. So, as we talk about what lies beneath, and as we follow scientists who have literally peered into the subsurface with instruments and drills, we have to remember that we're passing through a landscape already mapped many times over in languages and story systems that predate modern geology. Those systems don't need scientific validation to be real to the people who live by them. But when we put them next to modern research, something interesting happens. You start to see how different ways of knowing the same canyon can overlap, clash, or quietly confirm each other. To understand that scientific side, the part where people actually measure what's under those cliffs instead of just imagining it, we have to look at the tools they use to see into rock and darkness without blowing holes in a World Heritage site. If you want to know what's under a place like the Grand Canyon, you can't just start blasting tunnels and see what falls out. So scientists built a toolkit for peering inside without tearing it apart. None of these tools are magic X-ray vision, each one gives a narrow, partial view. Put together, they're more like puzzle pieces than a completed photograph. The simplest tool is mapping, but mapping here is doing a lot of work. It's not just draw the river. Geologists walk the rims, hike the trails, scramble into side canyons, and trace exactly where different rock layers show up and disappear. They note where faults cut through cliffs, where springs emerge, where sinkholes drop out of the surface. Over decades, those field notes turn into detailed geologic maps, which layers are where, how they tilt, where they've been broken or eroded away. That surface mapping is the base layer of everything else. It tells you if this sandstone is here on the south rim and that same sandstone is 20 miles away on the north rim, it probably also extends beneath the canyon in between. It doesn't tell you whether there's a cave in that sandstone, or a single huge cavern, or nothing but solid rock. It's like knowing the pages of a book are in the same order without knowing what's written on each line. Then there's drilling. In a national park, you can't just drop an oil field rig in the middle of a popular overlook. but there have been core holes drilled on the plateau around the canyon and in nearby basins for water, minerals, and research. A core is literally a cylinder of rock pulled from the ground. It shows you, in a few inches across, the exact sequence of layers, fractures, mineral veins, even tiny fossils. The power of drilling is that it's direct. You're not guessing what the rock looks like, you're holding it. The downside is obvious. A drill hole is a point, a thin, straight line through a three-dimensional world. You might drill 3,000 feet and never hit the big cavity that exists 200 feet to the side. You might miss a fault by a few meters and conclude the subsurface is undisturbed when it's actually broken to pieces nearby. Drilling gives you truth at one location and uncertainty everywhere else. To get beyond that single point, scientists use seismic methods. The idea is simple. Send a wave of energy into the ground and listen for the echoes. In practice, it's complicated. Small controlled sources on the surface, like specialized weight drop trucks or small explosive charges in shallow holes where that's permitted, send vibrations down. Those waves travel at different speeds through different rocks. Some bounce off boundaries between layers and come back. Arrays of sensors record how long that took. Turn that travel time data into a model and you can see where rock types change, where big faults offset layers, where there might be thick, low-velocity zones that suggest broken rock or large open spaces. But the image is blurry. Seismic surveys have limits on resolution. You're not getting a crisp outline of a secret chamber with furniture. You're getting smeared blobs that say this region is less dense, more fractured, or filled with something softer than the rock around it. Another approach is gravimetry, measuring tiny differences in Earth's gravity from place to place. Dense rocks pull a little harder. Less dense rocks, or big empty voids, pull a little less. Sensitive instruments can pick up those changes. In theory, a gigantic cavern system under part of the plateau could show up as a gravity low compared to the solid rock next door. The catch is scale. Gravimetry is great at seeing very large features, thick basins full of sediment, big intrusive bodies of dense rock, major faults. It's not going to outline a single hidden burial cave or a man-made room the size of a house. The signal from something that small gets lost in the noise of everything else, variations in rock type, topography, even how high above sea level you are when you measure. While those geophysical tools work from the outside in, cave surveys work from the inside out. When people can physically enter caves around the canyon, in places where it's legal and permitted, they map them the old-fashioned way. Tapes, compasses, laser rangefinders, increasingly 3D scanners. Each passage is measured, sketched, connected to the next, tied to a GPS point at the entrance. Over time, clusters of mapped caves reveal patterns, which rock layers tend to host voids, how far those voids typically extend, which directions underground water has preferred to move. That helps interpret what might exist where humans haven't been. But again, the bias is huge. You only map what you can reach. Vertical shafts, unstable roofs, cultural closures, and sheer remoteness mean large sections of the subsurface will never be mapped by people on ropes. Layered on top of all this is remote sensing, looking from above using satellites, aircraft, and drones. Some of it is just very detailed photography. Some uses LiDAR, a laser system that measures distance to the ground and can strip away vegetation to reveal subtle surface depressions or collapse features that hint at empty space below. Thermal imaging can pick up ground that's unusually warm or cool because of air moving through cracks in caves. Remote sensing tells you where to look more closely. It can flag, this mesa has an odd pattern of sinkholes, or that cliff face has dark, moist streaks that suggest a spring, but it doesn't see through rock. It's inferring what's beneath from what's happening on the skin of the landscape. Put this all together, and you start to see the pattern. Mapping tells you the architecture of layers and faults. Drilling gives you tiny cores of certainty. Seismic work sketches blurry internal boundaries. Gravimetry hints at big density contrasts. Cave surveys show real, accessible voids in a few zones. Remote sensing highlights subtle surface clues. None of these on their own can say, here's a hidden city, or nothing unknown exists. They also all run into hard limits in a place like the Grand Canyon. Rugged topography makes it difficult to lay out straight lines of sensors or drive heavy equipment. Protected status limits where you can drill, blast, or even fly. Cultural restrictions close some entrances entirely. And even when you get good data, interpretation is not neutral. Two geophysicists can look at the same seismic section and argue about whether a fuzzy zone is a fault, a change in rock type, or a zone of old collapse. That's why scientific results from the canyon can sound both confident and cautious at the same time. Confident about broad patterns, the thickness of certain layers, the major fault systems, the general depth to older rocks, and cautious about specific, localized claims. Scientists can say, here's what our tools show, and still leave room for debate about features they can't see directly, or about meanings those instruments are not designed to measure at all. And that tension between what the instruments can resolve and what they can't is exactly where a lot of the mystery stories move in. To see how much of the underground picture is actually solid, testable geology, we have to follow those tools into the canyon walls themselves and look at what the exposed rock record already tells us about the deep subsurface. The first thing the canyon gives you for free is the cross-section. You don't have to drill a 5-mile deep well to see how Earth is layered here. The river and its side streams already did the cutting. The walls are a vertical library of time, and geologists read that library the way a historian reads an archive. You start with what you can see, then use it to infer what you can't. Stacked along those walls are rock units with names you'll hear again and again: Kaibab limestone at the top, Coconino sandstone, Hermit, Supai, Red Wall, Muav, Bright Angel, Tapates at the bottom of the main Paleozoic stack. Below that, the tilted darker rocks of the Grand Canyon supergroup in places. And at the base of the deepest inner gorge, the really old stuff, the Vishnu schist and Zoroaster granite, part of the crystalline basement. Each of those layers is more than just a color band. It's an environment frozen. The Kaibab says shallow sea. The Coconino says wind-blown desert dunes. The Red Wall is a massive limestone built in warm, clear water with thriving marine life. The Tapets is a beach and shoreline deposit, full of pebbles and coarse sand laid down as an advancing sea drowned in older landscape. Those environments matter because they control what the rocks are like at depth, how strong they are, how easily they break, how likely they are to host groundwater, caves, or big voids. A thick, well-cemented sandstone will fracture differently than a ductile shale. A soluble limestone invites underground water to carve conduits. A pile of weak, clay-rich layers is more likely to deform plastically than to crack in clean, open joints. When geologists map those layers on the canyon walls, they're not just labeling scenery. They're tracing surfaces in 3 dimensions. The Red Wall is here on this rim. It's at that elevation on the opposite rim. It pops out in a side canyon 15 miles away. From that, they build surfaces in their minds, and increasingly in software, that extend under the plateaus, beneath the trails, below the tourist lodges. If a given limestone cuts across the entire region at roughly the same depth, it becomes a guide horizon, a layer that likely exists beneath you even if you never see it. You can test that picture where the river has cut deepest. In the inner gorge, the Paleozoic layers are gone, stripped away by erosion. You're staring at the basement complex, metamorphic rocks cooked and squeezed 1 billion years ago, intruded by younger granite. That's the foundational block the younger, softer cover rocks rest on. Where you see that basement rise high on one side of the canyon and sit lower on the other, you know a fault has shoved it up or dropped it down. That displacement doesn't stop at the waterline, it continues under the unseen floor. This is where the great unconformity comes in, and where the rock record really starts to hint at what's missing as much as what's there. In many parts of the canyon, the Tapets sandstone, about 500 million years old, lies directly on top of the Vishnu schist, which formed more than 1.5 billion years earlier. That contact is the great unconformity, a sharp surface where hundreds of millions of years of rock history are simply gone. Geologically, that surface is a scar. It says, at some point this area was land, uplifted, eroded down to a rugged surface of hard crystalline rock. Mountains were stripped away. Deep crustal rocks were planed off. Then a rising sea rolled in and dumped sand on top of that stripped surface. You can see the pebbles and cobbles of that ancient shoreline right on the contact in some places. For the subsurface, that unconformity is a major boundary. Above it, layered sedimentary rocks with predictable sequences, fossil content, and aquifers. Below it, complex basement with a very different structure, old faults, folds, intrusive bodies. In geophysical data, a contrast like that often shows up as a strong reflector or a density jump. In other words, the same surface you can walk up to in a side canyon is the one your seismic waves will bounce off miles away, where the river hasn't cut as deep. Ancient seas, deserts, and rivers leave other clues that reach below the visible walls. Those coastal tappete sands, the marine bright angel shales, the offshore Muave and Redwall limestones, together, they document a broad, shallow sea that once covered this region and extended well beyond the modern canyon. That tells you those same rock types continue in the subsurface, far from where you can see them. The Coconino's cross-bedded sand dunes are the remains of a huge desert. Deserts like that don't stop at county lines. They imply a sheet of porous sandstone stretching laterally for long distances. If that sandstone appears on both rims tilted the same way, you can reasonably infer it also arches beneath the river, forming a potential pathway for groundwater or a zone of weakness where future caves might preferentially form. The tectonic events recorded in the basement and in the tilting of the supergroup tell another part of the subsurface story. The Grand Canyon supergroup, those older tilted sedimentary and volcanic rocks you see in a few side canyons, were laid down in ancient basins, then faulted and tilted, then partially eroded before the younger Paleozoic layers were laid flat on top. That stacking of tilted, then flat, shows there were deep basins and big faults here long before the canyon existed. Many of those old structures extend downward and outward into rock that's never been exposed. When today's faults reactivate old zones of weakness, the result is a 3D network of breaks and shifts that control where the crust is fractured, where fluids move, and where the ground might be more broken or more solid at depth. Again, the pattern you can trace on the wall is the surface expression of something that keeps going below the floor. This is how visible geology becomes a guide to hidden geology. The canyon walls are not just a postcard, they're the outcrop sliced through a much larger block, and the logic is, if this slice looks like this along 277 river miles, then the unseen portions of the block probably follow the same rules, with local variations. It's not blind faith. It's pattern recognition backed up by drilling, seismic lines, and comparisons with similar rock packages elsewhere. At the same time, the gaps in that rock record are where imagination tends to rush in. A billion-year time jump at the Great Unconformity. Entire mountain ranges eroded away with almost no trace left in the canyon itself. Long intervals represented by a single razor-thin surface. For geologists, those gaps are invitations to study processes, how erosion can delete so much, how continents rise and fall. For some members of the public, they sound like places where anything could be hidden. Civilizations, vast chambers, unknown technologies, tucked into the missing chapters of Earth history. That tension is important. The rock record in the Grand Canyon is both richly detailed and undeniably incomplete. It anchors scientific models of the subsurface, and precisely because of its missing pages, it also leaves room for speculation. Before we get to the stories people tell about what might occupy that unseen space, we need to look at one more thing the canyon walls make uncomfortably clear. The fractures and faults that cut through all those layers and how they carve out real underground pathways the eye can't follow. Stand close to almost any canyon wall and you'll see it. The rocks aren't just layered, they're broken. Vertical cracks, diagonal seams, zones where the rock looks shattered instead of solid. To a geologist, that brokenness is not a cosmetic flaw. It's the plumbing and the fault lines of the region, written right on the surface. Start with faults. A fault is where the rock has actually slipped, one side moving relative to the other. The Grand Canyon region is cut by big named faults you can trace on a map. The Bright Angel Fault, the Toroep Fault, the Hurricane Fault, and others. They look like straight or gently curving lines that slice across all the rock units, from the rim rocks down through the inner gorge. In the field, they show up as valleys aligned in suspiciously straight trends, springs popping out in neat rows, or cliffs that suddenly offset a formation like someone shoved it sideways. When you see the Redwall limestone 300 feet higher on one side of the Bright Angel Fault than the other, that's not just a vertical shift in scenery. It means the entire block of crust on one side has been lifted or dropped relative to the other. That displacement doesn't magically stop where the river runs. It extends down into the basement and out under the plateaus, creating a 3D step in the subsurface. Then there are fractures and joints. These are cracks where the rock has broken but not necessarily slid. They tend to form in patterns, sets of parallel joints, cross-cutting sets at angles, sheets peeling off near cliff faces. The canyon's sedimentary rocks are full of them. Some joints follow regional stress fields from long past tectonic events. Others formed as the plateau was uplifted and flexed. Some are stress relief fractures that opened as the canyon was carved and the overlying weight was removed. To water, a hairline crack and a major fault are both invitations. In a massive limestone like the Red Wall, tiny fractures can widen over time as slightly acidic groundwater dissolves the rock. What starts as a millimeter-scale crack can become a finger-sized seep, then a tube, then a full-blown cave passage. In sandstones, joints and fractures become narrow channels where water can move more easily than through the tight rock around them. This is where you get hidden pathways. A plateau might look like a solid slab of stone from above. The rim trail feels firm underfoot, but inside that slab, every fault, every joint, every contact between a weak and a strong layer is a potential route for water and a potential zone of instability. Some of those pathways ultimately emerge as widely spaced seeps and springs on the canyon walls. Others never daylight. They connect to deeper groundwater systems and stay out of sight. Buried weaknesses add another layer to this. Long before the canyon existed, older faults cut the basement and the supergroup rocks. When later tectonic events stretched or compressed the region, those ancient scars acted like perforations in cardboard, easier to break again than the intact rock around them. Many of today's major faults are thought to reactivate those older zones. That means the visible fault lines on a modern map may sit right on top of structures that go far deeper than any canyon wall reveals. The relationship between that deep tectonic history and the present-day canyon is not just academic. The Grand Canyon itself is partly guided by where those faults and fractures made the rock more erodible. The Colorado River tends to exploit lines of weakness, turning fault zones into segments of the main gorge and using softer, broken rock as preferred pathways. Side canyons often line up with fracture sets or intersect major faults. The shape of the canyon is in part a map of where the crust was already wounded. Now, why do some areas feel utterly sealed while others seem suspiciously connected? A big reason is how these fractures interact with rock type. Imagine a thick, unbroken shale or siltstone layer sandwiched between two more brittle units. Fractures punching down from above may die out or be deflected along that weak, ductile layer instead of cutting clean through. That can create local caps or barriers to vertical water flow. You end up with perched aquifers, water pools sitting above less permeable horizons, feeding isolated springs that don't obviously tie into the deeper systems below. In contrast, where a fracture network cuts straight through multiple soluble and brittle units, say limestone over sandstone over fractured basement, you can get vertically integrated pathways. Water drops along faults, moves laterally at certain horizons, then drops again. Those are the places where a tiny surface opening can, in principle, connect into a much larger subsurface system. Not a vast empty cavern stretching for miles, but a linked web of joints, tubes, and conduits etched along the fracture architecture. From a scientific standpoint, those zones are gold. They're where groundwater can move quickly, where caves are more likely to develop, where mineralizing fluids once traveled, leaving ore deposits. They're also where rock is more fractured, where slopes are more prone to rockfalls, where tunnels or deep drill holes would encounter unpredictable conditions. Engineers, hydrologists, and hazard planners map them because that hidden structure affects everything from water supply to slope stability. From the standpoint of traditional knowledge, you often see a parallel response without the technical vocabulary. Certain ravines, springs, or cliff bases are treated with caution or reverence. Stories warn against lingering in some side canyons or entering particular openings in the rock. Some places are powerful, some dangerous, some restricted. You don't need a fault map to know an area is unstable, prone to sudden rockfall, or associated with disappearing water and strange echoes. Over generations, people notice patterns. Animals give a place a wide berth. The ground sounds hollow. The rock breaks unpredictably. The wind behaves strangely. Those observations get folded into teachings about where to go and where not to. So when scientists talk about fault damage zones, fracture corridors, and hidden conduits, and elders talk about places where the land is not to be disturbed, they may be pointing at the same underlying reality from different angles. The canyon is not a solid block with a neat, smooth underside. It's cut and recut by deep structures that concentrate water, focus erosion, and create both real pathways and real hazards in the dark. And nothing makes that clearer than what happens to water in a place that's supposed to be dry. From the rim, the Grand Canyon region looks dry enough to crack. Junipers claw at thin soil. Dust hangs in the air. The Colorado itself feels like the only obvious source of water. But inside the rock, the story flips. The plateau around the canyon is one of the more complex groundwater mazes in North America. It's just mostly invisible. Start with the basic problem. You have over a mile of stacked rock, each layer with its own personality. Some units are like concrete, tight, barely letting water through. Others are like giant sandstone sponges. Limestones dissolve. Shales smear and seal. Add in all the faults and fractures we just talked about, and the result is not one big underground lake, but a stack of partial plumbing systems, some connected, some not. Rain and snowmelt on the high plateaus don't sit around on the surface very long. They soak into porous rocks like the Coconino sandstone and the Kaibab limestone. Some of that water trickles down along fractures until it hits a layer that says no farther. Maybe a shale, maybe a less permeable siltstone. At that boundary, water shifts from vertical to sideways, pooling and creeping along the contact. That's how you get perched aquifers. Think of them as mini water tables stranded above the main, deeper system. They're not huge reservoirs, more like wet shelves inside the cliffs. Perched aquifers feed springs high on the canyon walls that seem to come from nowhere, green streaks and hanging gardens halfway down a sheer face, with no obvious source above and no obvious connection below. Lower down, deeper in the stack, there's another game going on. Water that manages to bypass those upper barriers, often by following faults or long persistent fracture zones, sinks much farther. It ends up in thicker, regionally extensive aquifers like those in the Redwall limestone or other carbonate units. Those deeper systems can move water for long distances, quietly, under plateaus that look bone dry on the surface. Major springs are where the hidden network breaks cover. Places like Roaring Springs on the North Rim, or the big discharge zones along the base of the Redwall, aren't just pretty waterfalls. They are the visible outlets of huge underground flow systems. Measurements of how much water comes out and how its chemistry changes over time tell hydrogeologists that some of that water has traveled tens of miles underground and spent decades or centuries in the rock. To figure out where it came from, scientists do something that sounds almost like tracking a rumor through a village. They spike certain recharge zones with harmless tracers, or they analyze the natural isotopic fingerprints of the water. They compare rainfall signatures on the Kaibab Plateau, snowmelt on the North Rim, and water sampled from different springs down in the canyon. If the fingerprints match, you've just mapped a hidden pathway. Sometimes the results are surprising. Water emerging at a spring halfway down one side canyon might chemically match snow that fell far away on a different plateau. That means there's a continuous, permeable route through what looked on a geologic map like a solid, unbroken wall. You don't need a cavern the size of a cathedral to do that. A network of widened fractures, solution-enlarged joints, and small conduits will move plenty of water. But the very fact that the system is fast and coherent enough to carry a recognizable signal means there are real voids and preferential channels in there, not just uniform, slow seepage. In other words, if you trace the water, you get a rough X-ray of the rock. You learn which layers behave as aquifers, which act as barriers, where faults are acting like pipelines, and where they're acting like dams. You find zones where water suddenly speeds up or slows down, which often correspond to changes in porosity, fracture density, or hidden cavities. Hydrogeology becomes a backdoor method for inferring where the subsurface is open, where it's tight, and where it's complicated. For people who've actually had to live here, that knowledge wasn't optional. Long before flow nets, dye tracing, and isotopes, communities on the rims and within the canyon were figuring this out with their lives on the line. If you don't understand where water appears, disappears, and reappears in a desert, you don't last long. You learn that certain alcoves always drip after storms, that some springs never fail even in dry years, that others run strong in winter and vanish in late summer. Over generations, that observation becomes map and calendar and warning label. Trails grow around reliable springs. Planting, hunting, and travel adjust to the timing of flows. Stories form around places where water emerges in improbable ways. Halfway down a cliff, from a crack in a dry wash, from a cave mouth that breathes cool air. Those are not just scenic features, they are survival infrastructure. Many tribes consider specific springs and seeps as sacred. From a Western scientific angle, it's tempting to file that under belief and leave it there. But when you overlay sacred sites with hydrogeologic maps, patterns emerge. Many revered springs are precisely those with unusual reliability, unusual chemistry, or unusual position in the rock column. They mark strong, persistent connections between deep and shallow systems. In other words, they sit at key nodes of the underground network. That overlap doesn't mean every sacred story is a coded hydrogeology lesson, or that every hydrogeologist has secretly been doing theology. It does mean both ways of knowing pay close attention to the same thing, where life-giving water breaks through the stone, and how that breaking through is anything but random. A spring that never runs dry in a land of drought naturally becomes more than just a faucet. It's a boundary between worlds, surface and subsurface, human and more than human, known and unknown. Elders might teach that such places are not to be disturbed, that offerings or protocols are required, that careless behavior there has consequences. A scientist might say the same area is sensitive to contamination, prone to collapse, or crucial for regional water supply. The language differs, the caution aligns. So when we talk about what lies beneath the canyon, water is not an afterthought. It is the main actor moving through all those faults and fractures, carving out voids, dissolving pathways, lubricating slopes, feeding ecosystems, and anchoring both modern management plans and ancient teachings. The desert is not as dry as it looks. It's just that most of its water lives in the dark, threading its way through stone, surfacing in a few, carefully remembered places. If groundwater is the invisible ink of the canyon, caves are the spots where that ink has eaten right through the page. There are a lot more of them than most visitors realize. Depending on how you count, there are thousands of caves, alcoves, and solution openings in the Grand Canyon region. Not one big continuous underground kingdom, but a patchwork, small rooms, twisting tubes, and modest chambers stacked at specific layers in the rock. Most of the true caves here form in limestones and similar carbonate rocks. Think of that red wall limestone band you see partway down the cliffs. It looks like one solid, vertical wall from a distance. Up close, it's riddled with openings. As slightly acidic water percolates through cracks, it slowly dissolves the rock, widening fractures into conduits, conduits into passages, and sometimes passages into rooms you could stand in. This is classic karst behavior. You start with rock that's chemically vulnerable and already fractured. Add time, water, and gravity. Let water find the easiest paths over and over. It doesn't carve randomly. It follows joints, bedding planes, and weak zones. The result is not a single, smooth subway tunnel, but something more like a hacked-together crawlspace system running along pre-existing weaknesses. But cave is a broad word, and lumping every hole in the canyon under it muddies things. There are natural caverns, voids primarily created by dissolution in rock like limestone, sometimes with recognizable features like stalactites, flowstone, or scalloped walls where water once raced through. These are what most people picture when they hear cave. Then there are fracture openings, places where the rock has simply pulled apart or sheared along a crack. They might look like caves from the outside, but if you go in, you're basically walking into a widened joint. No big hall, no hidden city, just a narrow high slot that ends where the fracture peters out or gets choked with debris. You also get erosional chambers and alcoves. These usually form in softer, more easily eroded rock below a tougher cap. Water, freeze-thaw, and gravity undercut the weaker layer, hollowing out a shallow room beneath a resistant ledge. Many of the big amphitheater-like alcoves that shelter archaeological sites or springs fall into this category. They can be impressive but are more like scoops out of the cliff than entrances to deep networks. On a map, all three can blur together as cave. Underground, their origins and limits matter a lot. Those limits are a big part of why so much of the canyon's subsurface remains unmapped. It's not because there's a grand conspiracy to hide some enormous hollow world. It's because even known caves are hard, expensive, and dangerous to explore. Start with access. Many openings are partway down sheer walls, hundreds of feet above the next ledge. Reaching them requires technical climbing, fixed lines, and careful timing around rockfall and weather. In desert environments, even getting to the base of the cliff might mean hours of scrambling through loose talus or navigating steep, exposed routes. Inside, conditions don't get friendlier. Canyon caves can be tight, with razor-sharp limestone, sudden vertical drops, loose breakdown boulders, and invisible pits buried under dust. A small rock dislodged at the wrong time can shatter a leg. A miscalculated squeeze can trap someone where rescue is nearly impossible. Many caves also intersect bat roosts or fragile minerals that can be damaged simply by a few footsteps. Then there's air. Some cavities have poor ventilation. Carbon dioxide can accumulate in low areas, displacing oxygen. Explorers have reported headaches, dizziness, and rapid fatigue in sections where gas has pooled. That's not a great place to push deeper just to see what's there. Layer on top of that land management and cultural concerns. Some caves intersect archaeological sites, burials, or sacred spaces. Agencies working with tribes often restrict access or keep locations quiet to prevent looting, vandalism, and unintentional harm. Other caves are closed seasonally or permanently to protect endangered bat species from diseases like white nose syndrome. The result is that even when scientists know about a cave, they might choose not to fully explore or publicize it. So what have cavers and researchers actually found in the Grand Canyon's hidden spaces? Plenty of interesting things, but nothing that supports the idea of endless cathedral-sized voids threading the entire plateau. Surveys show clusters of caves at specific horizons, like within the Red Wall or certain parts of the Muav and Kaibab formations. Many are modest in size, short passages, a few rooms, maybe a small vertical shaft. Some stretch farther, with multi-level mazes created by shifting water tables over time, where an old, dry passage sits above a still active, smaller conduit. These mapped systems reinforce what the hydrogeology suggests. Water tends to create interconnected networks where the rock is soluble and fractured, but those networks are patchy and layered. You get substantial local complexity, not a single giant void that neatly connects everything beneath the canyon. Instruments like ground-penetrating radar, seismic surveys, and careful mapping all converge on the same picture. Lots of spaces, different in shape and origin, mostly limited in extent and tied to specific geological conditions. There have been dramatic finds, mummified animals, well-preserved cultural materials, deep shafts dropping into unexpected rooms, a few large chambers that really do feel like subterranean cathedrals. Each one, when it becomes public, naturally captures the imagination. If this one huge room was hidden for so long, people think, what else could be out there? That's where the jump happens, from specific cave to sweeping legend. A single discovery gets retold, embellished, and sometimes detached from its original context. A big red wall cavern that extends a few hundred feet along a dissolution plain can, in the popular retelling, morph into a tunnel system miles long under the whole canyon. An erosional alcove with an archaeological site becomes a gateway to a valley of hidden chambers. The existence of real unmapped caves becomes proof, for some, of vast, deliberate secrecy. There's a psychological piece to this. The canyon already feels like a wound in the earth. Standing on the rim, you're looking into a space your eyes can't fully process in one glance. When you add the knowledge that there are further voids inside those walls, dark spaces that almost no one will ever enter, it's easy to imagine layers upon layers of hidden worlds. That feeling is real, even if the geology is more compartmentalized and constrained than the myths suggest. So yes, there are caves under your feet when you walk along the rim. Yes, many of them remain poorly known, and some will never be entered by humans. But what exploration has shown, again and again, is that these are local pockets tied to specific rock units and water paths, not endless ballrooms wrapped around secret cities. The gap between those two realities, the mapped chambers we can point to, and the immense unseen rock that still feels hollow in our imagination, is exactly the gap where the next part of this story took root. The tale of Egyptian artifacts, lost tunnels, and a canyon interior turned into a hidden civilization. In April 1909, a front-page story appeared in the Arizona Gazette that would, over a century later, still be fueling YouTube videos, late-night radio, and deep web message boards about the Grand Canyon. The article claimed that a man named G.E. Kincaid, working with the Smithsonian Institution, had discovered something astonishing in the canyon. A hidden cavern cut high into a sheer wall, packed with what sounded like old-world treasures. According to the report, inside this cave system were mummies wrapped in dark fabric, carved statues that looked Egyptian or perhaps Oriental, copper weapons, stone tablets with hieroglyphic-like inscriptions, even a main chamber supposedly large enough to hold several thousand people, with radiating side rooms arranged like a planned underground complex. The paper said the cave was reached by climbing 1,486 feet up a cliff face from the river, then following tunnels hundreds of feet into the rock. It described cross-shaped passageways, granaries, a crypt full of embalmed bodies in niches, and idols of what the author compared to Buddha. The whole thing read like a mashup of Egyptian tomb, Asian temple, and fantasy novel, relocated to a remote corner of the American Southwest. Names and institutions were dropped to give it weight. Kincaid said he was working under the direction of a Professor S.A. Jordan, allegedly tied to the Smithsonian. The article implied that the federal government and scientific establishment were quietly involved, studying the site in secret. It even suggested that this find could rewrite human history in North America. On the face of it, it's an irresistible story. Ancient transoceanic visitors, a secret man-made cavern complex, official involvement, a remote and difficult landscape, all the ingredients you'd need for a durable legend. But when historians and researchers started going back through the record, the foundation under that story got very shaky very quickly. Start with the basics. No photographs, no field notes, no specimen numbers, no accession records, no follow-up in scientific journals. If the Smithsonian had mounted a major excavation of a vast artifact-stuffed cave in the Grand Canyon, there should be a paper trail. The Smithsonian is bureaucratic almost by design. It records everything. The when, the where, the who collected what. Yet multiple checks of their archives have turned up no trace of Kincaid, no Professor S.A. Jordan attached to such a project, and no shipment of exotic mummies from the Colorado River corridor. Then there's the man himself. Outside of the Arizona Gazette article and a brief earlier mention also in that paper, G.E. Kincaid is a ghost. No easily verifiable census record, military record, or independent documentation tying that name and biography to a real individual doing river work in that era. It's not impossible he existed under a slightly different spelling, or that records were lost, but for someone supposedly involved in a history-shattering discovery, he leaves almost no footprint. The newspaper, meanwhile, was operating at a time when sensationalism sold. Early 20th century American papers regularly printed elaborate adventure pieces, some of them exaggerated, some partly fictional, some straight up invented, often mixing real places with embellished reports. The Arizona Gazette was not a major national outlet with rigorous fact-checking. It was a regional paper competing for attention, and dramatic frontier stories were a proven way to do that. When you read the article with that context in mind, certain details start to feel crafted for maximum drama. The precise but oddly round climb height, the convenient blend of Egyptian and Oriental motifs popular in the era's pulp fiction, the suggestion of a suppressed discovery without directly accusing any institution of a cover-up. It tracks closely with narrative habits of the time, right down to the flowery language. Researchers have also pointed out practical issues. The described location, about 42 miles up the river from El Tovar Crystal Canyon, is vague and doesn't map cleanly onto known geography. The idea of a massive, hand-hewn complex at that height, with no clear spoil piles or obvious entrance ever documented by later river runners, climbers, or aerial imagery, strains plausibility. Not impossible in a strict sense, but unsupported by any independent observation. So you have a single, uncorroborated newspaper account, names that don't show up in institutional archives, no physical artifacts that can be examined, and a style of writing consistent with period adventure sensationalism. That's why most professional historians and archaeologists treat the 1909 story with caution. Not because it's emotionally satisfying to debunk things, but because by normal standards of evidence, it's extremely thin. And yet the story refuses to die. It gets reposted, reinvented, and expanded. New versions add details the original never mentioned, tunnels connecting to other states, hieroglyphs matching specific dynasties, even links to lost tribes from religious texts. Internet forums point to modern maps with restricted zones and say, there, that's where Kincaid's cave must be. Any closed cliff face or off-limits side canyon becomes circumstantial proof that something is being hidden. Several things keep it alive. One is the setting. The Grand Canyon is huge, rugged, and full of real, documented caves that are hard to reach and harder to study. It's easy to believe that somewhere on those walls there could be a hidden man-made complex. The absence of casual visitors is baked into the terrain. Another is institutional silence as a blank canvas. When the Smithsonian says, "We have no record of this," people who already suspect cover-ups can interpret that in two opposite ways. Either the story was a newspaper fantasy, so of course there's no record. Or the records were destroyed or hidden, so of course there's no record. The same fact, no documentation, fits both narratives, depending on what you start with. You also have a long history of contested ideas about diffusion and contact. Could ancient Mediterranean or Asian sailors have reached the Americas before Columbus? That debate is complicated and ongoing in its own ways. The 1909 article gives people a ready-made smoking gun. If you already think old world visitors crossed the oceans thousands of years ago, a cave stuffed with Egyptian-style artifacts feels like the missing puzzle piece, even if it only exists in print. And there's the basic human preference for stories over footnotes. Secret Egyptian tomb in the Grand Canyon is a one-sentence hook that lodges in the brain. Complex, multidisciplinary evidence suggests gradual peopling of the Americas via multiple routes is accurate, but it doesn't grip in the same way. The Kincaid tale sits right at the crossroads of three categories: rumor, possibility, and evidence. Rumor, a single sensational article in a local paper, unsupported by independent sources, that describes an extraordinary discovery with no surviving physical traces. Possibility, the canyon absolutely does contain unknown caves. People have carved and modified rock shelters in many cultures. Ancient long-distance travel over water did happen in various parts of the world. In a very broad sense, none of those ideas violates physics or geology. Evidence, this is where things narrow. For the specific claim, a huge, human-made, Egyptian-style complex in the exact way the 1909 story describes, there is, so far, no verifiable physical evidence. No artifacts that can be analyzed. No directly linked inscriptions. No mapped entrance that matches the article. No institutional paperwork from the time that confirms the expedition. That doesn't logically prove such a site could not exist somewhere in the canyon. It does mean that, right now, what we have is a compelling narrative without the supporting structure that would move it from legend into documented history. Holding all three layers at once is uncomfortable. People tend to slide to one extreme. Either obviously real, they're hiding it, or obviously fake, only idiots believe it. But the reality sits in the murkier middle. The story is contested and unresolved, not because there's secret certainty on either side, but because the available evidence is limited and ambiguous. In a landscape where real caves are closed for safety, cultural or ecological reasons, and where even experts admit that large portions of the subsurface are poorly mapped, that ambiguity becomes fertile ground. The 1909 article doesn't just linger as a curiosity, it becomes a template. If one major discovery could be hidden or fabricated, what else might be? That question, more than the specifics of mummies or hieroglyphs, is what links the Kincaid legend to modern claims about restricted zones, hidden chambers, and official silence. And that's where we go next. From one old newspaper story to the broader ecosystem of closures, regulations, and rumors that surround the canyon today. If you want to understand why so many people are convinced there's something huge being hidden under the Grand Canyon, you have to start with something a lot less dramatic than secret vaults and lost civilizations. You have to start with area closed. On paper, the reasons are dull. Park managers, tribal nations, biologists, and geologists sit in meetings and argue over maps. They're not deciding where to bury alien tech. They're deciding how to keep people from falling off cliffs, trampling fragile sites, or destroying a spring ecosystem that took 10,000 years to form. Some closures are basic safety. The Grand Canyon is not a friendly place to the unprepared. Sheer walls, loose rock, extreme heat, flash floods. A lot of the vertical terrain that looks like perfect spot for a secret cave entrance is, in reality, perfect spot to die if you try to scramble up there. So certain ledges, climbs, or unofficial routes get closed. Not because there's something behind them, but because search and rescue is already busy enough. Then there's conservation. Those seeps and springs we talked about earlier, many of them support plant communities found almost nowhere else. Cave entrances can be habitats for rare bats. Archaeological sites sit in alcoves where a single footprint, a single careless hand, can destroy what's left of an ancient floor or a faint pigment line. So zones get designated as research only or closed to casual access, or open only with a specific permit. And then there's culture. Some places in and around the canyon are not just scenic or historically interesting. They're sacred. They're woven into living religious practice. They're used for ceremony by Havasupai, Hopi, Navajo, Zuni, Paiute, Hualapai, and other nations that have long, deep ties here. For those communities, putting a GPS point on a public website and inviting millions of tourists to come look, snap photos, and post TikToks isn't transparency, it's desecration. So agreements get made. Locations are kept vague in public documents. Certain cliffs, mesas, or side canyons are off limits unless you're a tribal member with a purpose for being there. Federal law actually requires agencies to consult tribes about how to protect sacred and traditional use sites. And one of the tools on the table is confidentiality. From a land management perspective, all of that is ordinary. Annoying to some visitors, yes, but ordinary. From the outside, though, it can look very different. If you're already primed by stories like the Kincaid Cave, if you're looking at the canyon through a lens of they're hiding something, those same closures start to feel like confirmation. You pull up a map, you see a block of terrain marked off limits. You see permits denied for certain commercial trips. You hear that GPS coordinates for a ruin have been redacted. It's easy to jump from restricted for safety and cultural protection to restricted because there's a massive hidden chamber full of artifacts they don't want us to see, especially when explanations are short and bureaucratic, closed to protect resources, access limited due to sensitivity. Those phrases are technically accurate. They also leave a lot of room for imagination. The basic pattern shows up over and over, not just in the Grand Canyon. A cave is closed because of white nose syndrome in bats. For some people, that becomes proof it's a portal, or a military tunnel, or the entrance to a buried city. A cliff dwelling is never marked on public maps because the tribe asked for privacy. That gap becomes the site they won't admit exists. A research area has locked gates and instruments on tripods. Must be a cover. Couldn't possibly just be hydrogeologists measuring groundwater. The canyon's layered jurisdiction doesn't help. You've got a national park, tribal lands, a national monument, national forest, private inholdings, and in some areas nearby Department of Defense or Department of Energy projects. Different rules in different patches, different signs, different kinds of fences. To someone who knows the regulations, that patchwork is just the messy reality of public land management in the American West. To someone scrolling satellite images looking for patterns, it can look like a carefully constructed net of secrecy wrapped around key spots. Sacred site confidentiality adds another twist. When tribal elders say, "We don't talk about that place publicly," outsiders sometimes hear, "We're hiding a physical secret there." In many traditions, that silence isn't about a hidden object. It's about respect. Knowledge is shared within the community at the right time, with the right roles, not broadcast to millions of strangers who treat everything as potential content. But from the outside, that kind of boundary can be misread as evidence of a cover-up. Why won't they tell us what's there? What are they afraid we'll find? The fact that spiritual privacy exists at all becomes fuel for hidden truth narratives that have nothing to do with the beliefs or intentions of the people actually connected to the place. There's a real tension here. On one side, you have legitimate claims to privacy and protection, a tribe saying, "This cliff is part of our origin story, please don't turn it into a hiking challenge on Instagram." A cave biologist saying, "If we let everyone in here, the microclimate changes and the entire ecosystem collapses." A park ranger saying, "We've pulled too many bodies off that slope, we're closing it." On the other side, you have a public that has been lied to before by governments and institutions. From secret bomb tests to surveilling citizens, there's a documented history of things being done in remote places without honest explanation. That history trains people to assume the worst when they see a locked gate and a vague sign. The leap happens right there, in that gap between necessary discretion and justified distrust. Hidden truth narratives take routine management decisions, closures, redactions, limited permits, and plug them into a dramatic story arc. The canyon stops being a place with specific hazards and specific cultural obligations. It becomes a stage where they are always hiding it, whatever it is this week. Egyptian mummies, giants, unknown technology, a suppressed geological discovery, a rewriting of human origins. The irony is that sometimes those closures really are hiding something from you. But usually what they're hiding is not a civilization, it's vulnerability. Vulnerability of a spring that can be ruined by one careless chemical spill. Vulnerability of a burial site that can be looted in a single night. Vulnerability of a ceremony that can't survive an audience. Sorting this out means holding a few distinctions at once. Not every locked gate is a nefarious secret. Not every request for cultural privacy is an attempt to erase history. At the same time, not every official explanation deserves blind trust. It's reasonable to ask questions. It's reasonable to want evidence. The challenge is to separate three categories: safety measures meant to keep people alive, protective measures meant to keep places and traditions intact, and claims that go far beyond the available facts. In a landscape as vast, as undermapped, and as emotionally charged as the Grand Canyon, those categories blur easily. Rumor spills into possibility. Possibility is presented as proof. And before long, a red line on a management map becomes another node in the story web of what might lie beneath. To get any closer to the truth, not the capital T truth of a perfect answer, but a clearer picture of what actually exists, we have to look at what archaeologists and geologists have found in the canyon, and just as importantly, what they haven't. When you strip away the legends and the redacted PDFs, you're left with the one thing that actually has to carry the weight of all these claims: evidence in the ground. And there's a lot of it. Archaeologists have documented thousands of sites in and around the Grand Canyon. Not theoretical locations. Not a friend of a friend said. Actual mapped, recorded, repeatable places. On the open benches above the river, you get habitation sites. Clusters of stone foundations where families once lived, outlines of rooms, hearths, grinding areas. Up on ledges and in alcoves you find granaries, small walled storage rooms tucked into impossible-looking spots, built with rock and mud plaster, designed to keep rodents and moisture away from precious corn and seeds. You see trails worn into the rock, not by one expedition, but by centuries of feet. Some of those routes are still used today by tribal members and river runners. Others are now faint lines that stop at ruined stairways chiseled into cliffs. On the walls, there's rock art, pictographs, painted figures made with mineral pigments, plant dyes, animal fat, petroglyphs, images pecked or carved into the desert varnish on cliff faces and boulders, spirals, bighorn sheep, human figures, abstract designs that may map out journeys, seasons, or stories, different styles, different ages, a visual record layered over time. Then there's the small stuff, the material culture that never shows up in sensational headlines because it doesn't scream lost civilization, it whispers ordinary life. Pottery sherds, some plain, some decorated in distinct regional styles that tie the canyon into larger trade networks. Stone tools and flakes from making them, grinding stones worn smooth from countless hours processing plants, bits of basketry in dry caves, corn cobs, charred seeds, pollen. Occasionally, rare preserved textiles or sandals in arid shelters. You put these pieces together, and a picture emerges that's far more grounded, and in many ways more impressive than a one-time discovery of a hidden vault. What the evidence shows is continuity. People have been using this region for thousands of years, not as a random camping spot, but as part of long-term homelands and seasonal rounds. Moving up and down in elevation with the seasons, farming in some places, foraging in others, hunting along specific routes, storing surplus where it would be safe, performing ceremonies in particular locations. You see adaptation to an extreme environment that most modern visitors barely survive for a weekend. Cliff edge granaries are engineering solutions to scarcity. Rock art placed near water sources or along routes looks like wayfinding and memory made visible. Trails dropping from high plateaus to the river mark out the logistics of carrying salt, obsidian, turquoise, food, stories, and news between communities. When archaeologists study changes in pottery, architecture, or site locations through time, they're not just cataloging artifacts for fun. They're tracing how people responded to droughts, shifts in climate, new trade opportunities, conflicts, alliances, religious movements. The canyon becomes not a static backdrop, but an active partner in how societies evolve. None of that requires a hidden, non-indigenous super-civilization with advanced technology. It does require deep, long-term indigenous presence and expertise. And this is where the contrast with the wilder claims matters. Real archaeology in the Grand Canyon is already extraordinary. It shows complex networks, sophisticated land use, spiritual geographies, and knowledge systems that kept people alive here for millennia. But it looks like what it is: the record of human communities who were and are native to this region. The stories about Egyptian tombs, giant skeletons, or vast underground cities with metal doors and electric lights try to leapfrog all of that. They often erase or sideline indigenous histories in favor of an imported, exotic narrative that feels more dramatic to some outsiders. When you ask, okay, what's the evidence for those? The answer gets thin quickly. Established archaeology runs on repeatability and documentation. Sites are surveyed, mapped, photographed, dated. Artifacts are cataloged. Reports go into state and federal databases. Tribes are consulted. Even when the public doesn't see the coordinates, other professionals do. For the alleged underground cities, you don't get that paper trail. You get 1900s newspaper articles, second or third-hand accounts, missing field notes, and no verifiable site coordinates that hold up when checked against known topography and geology. That gap between what's documented and what's rumored isn't because archaeologists ignore anything that doesn't fit their worldview. It's because at some point, extraordinary claims need more than a good story. They need the same kind of durable, checkable evidence we rely on for everything else. There are also practical reasons why even very real sites might seem invisible from the outside. Preservation is a constant problem. The canyon's dry shelters can preserve fragile materials beautifully, but once a site is exposed to heavy visitation, vandalism, or even just too many boots, it disintegrates fast. Petroglyph panels get carved over with initials. Pottery scatters and disappears into backpacks. Floors that held traces of ancient footprints get obliterated. Access is another filter. Many archaeological sites are in places that are insanely hard to reach without technical skills and time. Remote side canyons, exposed ledges, cliff alcoves. Some are on tribal lands, where visiting or photographing them without permission isn't just rude, it's a serious violation. Others are in zones closed to general use for the safety and cultural reasons we just talked about. And then there's disclosure. Park archaeologists, tribal historic preservation offices, and university researchers routinely withhold exact locations in public documents, not as a power move, but because as soon as a precise GPS point hits the internet, looting risk skyrockets. Federal and state laws actually encourage agencies to keep sensitive data out of public circulation for this reason. From outside, that can feel like they won't tell us what they've found. From inside, it's, we know what happens when we do, so we end up with two very different kinds of hidden, hidden as in protected burial sites, shrines, fragile habitation sites, rock art panels whose locations are deliberately blurred or never published. Places real people still care about and visit, and hidden, as in hypothetical, sprawling stone metropolises and cavern systems that, so far, leave no hard trace in the archaeological record despite a century of river trips, surveys, and research. Those categories get conflated all the time. Someone hears that archaeologists found a big site in a cave but won't say where, and that fact, true in some cases, gets folded into a larger narrative about suppressed discoveries that rewrite human history. The nuance about we're protecting a known ancestral site from looters drops out. What's left is just, they're hiding something big. Sorting out what's actually in the ground from what's in the rumor mill means holding both realities at once. Yes, the canyon is full of archaeology that most people will never see. Yes, some of it is undocumented or poorly understood and may still surprise researchers. And at the same time, the patterns we do see, across thousands of recorded sites, point very strongly toward long, sophisticated indigenous histories, not an erased global civilization tucked away in a perfectly preserved underground city. That doesn't make the real record less powerful. If anything, it makes it more demanding. It asks us to be impressed, not by a one-off spectacle, but by centuries of people reading rock, water, and weather closely enough to live here, leave their mark, and still be part of the story today. And once you see that, a different question starts to matter more than, what haven't they told us? It becomes, given what we actually know, what could still realistically be down there? To answer that, you have to switch from thinking like a treasure hunter to thinking like a rock. Because whether vast hidden spaces can exist under the Grand Canyon doesn't start with legends. It starts with what kind of stone is there, how it formed, and how it breaks. The canyon isn't one uniform block of rock, it's a stack. You've got hard, cliff-forming layers like Coconino sandstone and Redwall limestone. Softer, slope-forming layers like the Bright Angel shale. Older, even tougher metamorphic and igneous rocks down near the bottom. Each one responds differently to water, stress, and time. Some of those layers are great candidates for caves. Others, not so much. The rock type that really matters for big voids is limestone. The canyon has a lot of it, especially the Redwall. Limestone dissolves in slightly acidic water. Rain picks up carbon dioxide from the atmosphere and soil, becomes weak carbonic acid, and over thousands to millions of years can carve out channels, tubes, and chambers. That's what creates karst landscapes, sinkholes, underground rivers, caverns, where you have thick limestone layers, enough water moving through fractures, and the right structural conditions, you can absolutely get large caves. Not hypothetical, real. Some are mapped, others almost certainly aren't. There are known caves in the Grand Canyon region that are genuinely impressive. Rooms large enough to stand in, twist through, get lost in if you're careless. Some hold ice, some hold archaeological material, some are still being explored by technical teams who map a little farther each year. So if the question is, could there be undiscovered caves, even big ones? The geologic answer is yes. But that's only part of the story. Not every layer is built to host a cavern the size of a sports arena. Shales and mudstones tend to deform and creep rather than hold open large stable voids. Sandstones can form caves, usually along bedding plains or where cement has dissolved out, but those tend to be more like alcoves or narrow tubes than cathedral-scale halls. The really deep rocks, the ancient Vishnu schist and granite, are very hard and strong, but they're also heavily fractured. Water moves along those fractures, but it doesn't usually carve big open rooms there. You get joints, cracks, minor voids, not vast underground basilicas. Then there's structure. The canyon is cut by faults and fractures that create pathways for water. They also create zones of weakness. A chamber can only get so big before its own roof becomes unstable and collapses. You see that in smaller scale all over the place. Alcoves formed by rockfalls, overhangs that have spalled off, talus piles at the base of cliffs. So, where are substantial hidden cavities geologically plausible? Thick limestone units, the Redwall, and some deeper carbonate layers. Areas where those units are at the right elevation, intersecting with faults or fractures that have channeled water for long periods. zones where the rock above is strong enough to act as a roof without immediately failing. Where are they less likely? Right beneath the main river corridor in soft, slope-forming units, deep in the highly fractured metamorphic basement, directly under huge cliff faces where every void tends to get expressed as a visible alcove or collapsed amphitheater instead of staying neatly concealed. That brings us to scale. There's a spectrum between void in rock and underground city. At one end, you have isolated voids, small to medium-sized pockets created by dissolution, gas bubbles in lava, or local collapses. Think crawlways, small rooms, rock shelters. These exist all over the place. Many are never documented beyond a GPS point in some geologists' field notes. Next, you have connected cave networks, systems where multiple chambers and passages link up into something that starts to feel like a maze. You see those in famous karst systems around the world. Mammoth Cave in Kentucky, Carlsbad Caverns in New Mexico. In those places, the geology, hydrology, and time window all line up to create truly extensive underground labyrinths. And then you have fantasy-scale visions, multi-level stone metropolises with broad avenues, ventilation shafts, engineered infrastructure, whole populations living entirely below the surface with no external trace. Geologically, nothing in the canyon rules out caves, or even pretty large rooms. But the jump from room you can fit a few dozen people in to city that could hold thousands and be traversed with carts is enormous. Not just in volume of empty space, but in the engineering required to keep it from collapsing, ventilated, supplied with water, and connected to the surface. If that scale of void existed in dissolving limestone under active erosion, you'd expect some signals. Subsidence features, sinkholes, unusual drainage patterns, collapsed roofs leaving conspicuous amphitheaters, anomalies in gravity or seismic data, pieces of the roof showing up as distinctive boulders and blocks. Comparable landscapes give some perspective. Mammoth Cave's system extends for hundreds of miles, but it's in a thick, continuous limestone plateau, not a deeply incised, hyper-eroded canyon. Carlsbad Caverns' huge rooms formed under very specific geochemical conditions involving hydrogen sulfide and sulfuric acid. Massive cave networks in China's karst regions happen under broad uplands with huge recharge areas and long, uninterrupted periods for dissolution. The Grand Canyon has had a complex history. Parts of its limestone layers were uplifted, eroded, and dissected multiple times. Water doesn't quietly meander in a single stable horizon. It's constantly being rerouted by changing base levels as the river cuts down. That tends to chop and isolate cave segments instead of preserving continent-scale underground boulevards. That doesn't mean everything is known or mapped. Cavers still find new passages. Hydrologists still puzzle over exactly how water moves through some sections of the plateau. There are caves with entrances so small or remote almost no one has ever been inside. There are voids that might only be detectable with very targeted surveys. Scientific caution actually leaves a lot of room for discovery. Geologists will say, we haven't found any evidence of a giant underground city, and also we can't claim we've mapped every single void in a landscape this big and complex. Both statements can be true at the same time. What that caution doesn't do is automatically validate the most extreme interpretations. Saying, there could be unmapped caves and even sizable chambers in certain rock units, is very different from saying, therefore it's reasonable to assume a vast engineered metropolis exists and is being systematically concealed. The rocks put boundaries on what's possible. Within those boundaries there is genuine mystery and room for surprise. Outside those boundaries, you start needing not just undiscovered geology, but undiscovered physics, undiscovered engineering, and a level of coordinated secrecy that hasn't left much of a trace in a heavily studied national park. So when we ask what might still be hidden, a geologic perspective doesn't shut the door. It narrows the frame. It points us toward specific layers, specific structural settings, specific kinds of spaces that are plausible. It makes big claims prove themselves, instead of letting them ride on the simple fact that not every corner of every cave has been illuminated yet. If geology narrows the frame, modern imaging is the flashlight we shine into that frame. Because for all the talk about secret chambers and things they don't want you to see, the canyon is one of the most scanned, mapped, and modeled landscapes on Earth. Start with LiDAR. LiDAR is basically laser range finding from the air. Aircraft or drones fire millions of laser pulses at the ground, time how long they take to come back, and build a hyper-detailed 3D model of the surface. You can peel away vegetation. You can see subtle breaks in slope, collapsed depressions, old landslides, hidden terraces. In forested regions, LiDAR has revealed lost cities and ancient road networks under jungle canopies. That's real. That's documented. In the Grand Canyon region, LiDAR and high-resolution topographic mapping have done something similar, but with rock instead of rainforest. They've highlighted subtle sinkholes and solution dolines on the plateau above the canyon where water is dropping into karst systems. Old, buried channels cut into the limestone and then partially filled in. Landslide scars and rockfall runout zones that mark places where the subsurface was weak or undercut. These are anomalies in the technical sense, spots where the topography doesn't look like the surrounding terrain and needs a geologic explanation. An anomaly is just that, something that doesn't immediately fit the smooth pattern. A depression that's deeper than the surrounding surface. A linear feature that cuts across normal drainage. A bulge where you'd expect flat ground. But anomaly does not mean proof of hidden structure. It means flag for further investigation. Take satellite data. High-resolution satellite imagery and digital elevation models show the canyon's surface in extraordinary detail. You can trace fracture sets across miles. You can see how small tributaries line up with major joints and faults. You can spot where springs consistently emerge along particular contacts. Hydrologists use that to back-calculate where water is likely traveling underground. They match surface features, wet seeps, lush hanging gardens, persistent snowmelt spots, to subsurface pathways tied to specific layers. Again, that reveals patterns that aren't obvious at eye level. Linear alignments of springs that point to a shared conduits in limestone. Terraces and benches that might mark old levels where a river once flowed, long since abandoned and partially buried. Collapsed zones where roofs of old caves have failed and produced sinking ground or amphitheaters. Those are indications of voids or past voids, but they're not blueprints of some vast room. They're hints, not X-ray vision. Speaking of X-rays, there are also geophysical surveys. You can't drill a grid of boreholes through a national park just to satisfy curiosity, so scientists use indirect methods, gravity measurements, magnetic surveys, seismic work, electrical resistivity. Gravity surveys measure tiny variations in how strong Earth's gravity pulls at different points. Less dense rock or significant void space can produce a small gravity low. More dense rock, a gravity high. Seismic methods send waves into the ground, either from small controlled sources or from natural events, and record how those waves move and bounce. Different rocks, different densities, and different fluid contents change the wave speeds and reflections. Electrical and electromagnetic methods measure how easily current or electromagnetic fields move through the subsurface. Water-filled fractures, clay-rich zones, and air-filled voids all have distinct signatures. In the Grand Canyon region, these methods have revealed things that matter if you care about what's beneath. Ancient buried channels, valleys cut into older rock, filled with younger sediments, completely invisible at the surface, but important for understanding past drainage and where water might still move. Zones of structural weakness, faults that are more broken up than the rock around them, sometimes acting as conduits for water, sometimes as barriers. Karst systems, areas in the plateau carbonates where dissolution has created enough porosity and voids to register as distinctive zones in gravity, resistivity, or seismic data. Do these show perfectly outlined giant caverns? No. What they show are regions where the rock is more porous, more fractured, or more riddled with small to moderate voids than average. Think Swiss cheese tendency, not hollow skyscraper. You can have a gravity low that suggests less dense than expected. That might be a large cave. It might also be a thick package of unconsolidated sediment. It might be fractured rock with water in it. It might be a combination of subtle features spread over hundreds of meters. Without direct access drilling, a tunnel, a big natural opening, you don't get to skip straight from signal to secret hall. That's the gap between suggestive data and conclusive identification. Suggestive data looks like this: a line of springs at the same elevation along a limestone contact, a localized gravity low coincident with known karst features on the surface, seismic velocities that slow down in a particular zone, hinting at increased fracturing or void space. Conclusive identification would require a mapped cave or tunnel that physically occupies that zone. Direct imaging that clearly differentiates air-filled space from rock and sediment at a resolvable scale. Multiple independent surveys that all say the same thing. Most of what we have for the Grand Canyon's subsurface falls squarely into the suggestive category. Enough to know there are complex networks of conduits, perched aquifers, and half-collapsed relic caves within certain units. Not enough to say, here is a chamber of this exact size and shape, let alone, here is an engineered structure. High-resolution mapping has also helped correct our mental picture of hidden topography. A lot of what feels remote or concealed from the rim, side canyons, alcoves, deep alcove within alcove structures, pops out clearly when you view LiDAR-based terrain models. Route planners, rescue teams, and geologists use that to predict where people can travel, where rockfalls are likely, and where caves are more probable. If there were repeated indications of enormous coherent voids, kilometer-scale anomalies, systematic subsidence fields, large gravitational lows with matching seismic signatures, you'd expect that to show up in the professional literature, if only as, we don't yet know what causes this. Instead, the published work paints a picture of a highly dissected, partially karstified plateau feeding a deeply incised canyon. Complex, yes. Full of smaller voids, yes. But consistent with what you'd expect from that rock stack under that climate over that timescale. Remote sensing hasn't killed the mystery. It's sharpened it. It tells us where hidden channels likely run, where roofs may be thin, where void-related features exist. It also sets some practical ceilings on how large and continuous those voids can be before they would start shouting in the data. Within those limits, there is still plenty of unknown. Beyond them, you leave the realm of current evidence and step into speculation. And that's where a lot of the stories about what must be down there decide to live. If modern instruments mark the limits of where we can safely speculate, traditional warnings often mark the limits of where you should even try to go. Because before there were LiDAR flights and gravity surveys, the people who lived around this canyon had something else. Generational memory of what goes wrong when you underestimate stone, water, and darkness. When elders say, "Don't go there," it's easy from the outside to hear only mysticism. Cursed place, spirit canyon, hole where beings come and go. But listen to how those warnings actually work. A spot is avoided because the ground is angry, or the rock can fall without warning, or something down there steals your breath. That might sound like mythic language, but the pattern of what's being described lines up with what rangers, rescue teams, and geologists put in their own risk briefings. Unstable slopes that slough off even in clear weather. Slots that funnel a storm from miles away into a sudden wall of water. Low caves with bad air, CO2, radon, or oxygen-poor pockets that make people dizzy, then unconscious. Hidden vertical drops you don't see until you're standing at the edge, or until loose gravel gives way under your boots. Places where water looks clean but is loaded with pathogens, or where dead animals collect and rot in side pools. You can express those as zones of rockfall hazard, flash flood exposure, confined space asphyxiation risk, and biological contamination. Or you can say, this place is dangerous. The spirits there don't like people. Functionally, they do the same job, keep you alive. In a landscape like the Grand Canyon, land knowledge is survival hardware. You carry it in stories because everyone can remember a story. Not everyone can remember a USGS hazard map, so warnings get encoded in forms that stick. A child hears that a certain alcove is where a powerful being lives, and if you whistle there, it will answer and take you. Maybe what that actually encodes is, sound echoes strangely in that narrow overhung hall. Loose blocks high above can be triggered by vibration. People have died there under rockfall. Don't make noise, don't linger. A tale says that a dark crack eats dogs and doesn't return them. That may recall a real sinkhole or cave entrance where animals and people vanished. In modern caving terms, vertical shaft, undercut entrance, no easy way out. A rule that says do not drink from that spring, it belongs to someone else, might encode generations of observation that drinking there makes people sick, or that the flow is intermittent and needed for ceremonial use, not casual refreshment. Sacred contamination rules can double as environmental protection. If you're told that certain side canyons and seeps are off limits because they're used for ceremony, you're also protecting fragile microhabitats and rare water sources from being trampled, polluted, or overused. A ban on defecating or disposing of the dead in particular spots because they are sacred is also a basic public health measure around small critical water supplies. Spiritual language and practical outcome are intertwined. Look at how modern authorities talk about the same terrain. National Park Service warnings. Do not enter mines and caves because of low oxygen, toxic gases, unstable timbers, and disease-carrying bats. Flash flood signage. A blue sky overhead doesn't mean safety. Storms 50 miles away can send a deadly surge. Closures, areas shut down because of loose rock, undermined trails, or sensitive habitat. The tone is different. The logic is similar. Elders might say there are places where the dead walk. You shouldn't bring children there. Park staff might say there are archaeological sites and burials here. Disturbing them is illegal and dangerous. We don't want people wandering around unsupervised. Both are enforcing a boundary. Geologists warn that certain formations, like the crumbly slopes of the Bright Angel Shale or the rotten ledges of the Supai, tend to fail without much warning. They'll say, "Don't camp under that," or "Don't shortcut that slope." Tribal guidance may frame the same area as a path reserved for specific purposes, or a zone where the rock listens and doesn't forgive. Different epistemologies, same outcome. You don't treat that ledge like a park bench. This is where the usual stereotype, ancient superstition versus modern science, falls apart. Because once you recognize that oral traditions often braid together memory, ethics, and hazard mapping, the question stops being, is this story literally true? And becomes, what does this story remember? Maybe it remembers a flash flood that wiped out a hunting party in a narrow side canyon. A cave where a group suffocated after lighting too many fires in stale air. A rock fall that buried a camp and led to that alcove being abandoned. An illness that followed drinking from a certain seep after upstream contamination. Over generations, that event gets retold, abstracted, layered with spiritual meaning. But the core is still a warning. Do not repeat this mistake. Modern risk management is full of the same pattern, just with different aesthetics. We turn airplane crashes into procedural changes and training scenarios. We turn industrial accidents into safety codes and certification programs. We tell new workers, don't do X, because 30 years ago someone did and they died. In a small community living next to a canyon that can kill you in a dozen ways, you do that through story, song, taboo, and place names. It's not that every spiritual claim has a one-to-one translation in geological terms. Some elements are cosmological, dealing with beings, origins, duties, relations between humans and non-human worlds. But those dimensions don't cancel the practical layer. They coexist. A site can be dangerous because the rock is fractured, the cave is oxygen poor, and it's also a place where, in a community's understanding, powerful presences dwell and certain behaviors are required. From the outside, you can acknowledge, we may not share the same cosmology, but we can respect that these narratives have kept people alive in this landscape for a long time. So when you hear an elder's warning about going into some crack or cave in the canyon walls, you don't have to choose between prophecy of monsters and pure coincidence. You can also choose a third option, layered knowledge. A story that holds a moral, a cosmology, a history of past disaster, a set of land use rules, and a rough geological hazard map all at once. Reframed that way. The question isn't why were they afraid of what lies beneath, but what did they see over how many generations that taught them to be cautious there at all? If layered knowledge is how people who live with the canyon talk about it, flattened mystery is how people who visit for a week tend to sell it. Because once you have a landscape this big, this hard to see in full, and this easy to photograph from only a few safe angles, you've created perfect conditions for the imagination to run ahead of the evidence. The Grand Canyon became famous in stages. First, as a blank on the map that early Euro-American explorers described in almost apocalyptic terms. Awful grandeur. Incomprehensible abyss. A place where words were supposed to fail. then as a proving ground for adventure writing. 19th and early 20th century accounts of running the river, crossing the plateau, nearly dying of thirst. The canyon as character, hostile, testing, sublime. That kind of writing has a built-in incentive. If you admit how much help you had, how many guides were local, how much of your discovery was already well known to people who lived there, the story loses its edge. So the canyon gets framed as unknown, unknowable, unmastered. Later, it becomes one of the most photographed tourist sites on Earth. Millions of people standing on the same handful of overlooks, pointing cameras at the same few vistas, then leaving with the sense that they've seen the canyon. But what they've seen is an enormous, beautiful wall at a distance. They haven't seen most of the side canyons, they haven't seen the caves. They haven't seen what's under the river or behind the cliff faces. They know, because the brochure told them, that there are areas closed to the public and restricted for safety and cultural protection. Put that together, huge scale, very partial access, and the knowledge that some places are off limits, and you've just drawn a giant blank space in people's heads. And blank spaces get filled. Adventure magazines and outdoor channels step in first. They run stories with titles like Into the Unknown Grand Canyon or Exploring the Hidden Realms Beneath the Rim. Most of those pieces are about tough hikes, narrow slots, maybe a technical descent into a side canyon. Real places, real effort, real risk. But because we hiked a steep, dusty trail and saw some cool formations doesn't sell as well as we descended into a forbidden underworld. The language gets dialed up. The canyon becomes a labyrinth, a maze, a secret world. Then pseudo-history and speculative documentaries add another layer. Any stray phrase from an early newspaper, any ambiguous report, any odd gap in the record becomes raw material for ancient secrets of the Grand Canyon. What's the government hiding? Evidence of lost civilizations. The pattern is familiar. You start with something true but limited. Yes, there are many caves in the canyon we haven't mapped in detail. Yes, some archaeological sites are not publicized to prevent looting and vandalism. Yes, tribal nations request closures and restricted access around places they consider sacred. Yes, the Park Service and federal agencies enforce those closures. Those are straightforward facts. Then they get stacked. Many caves becomes countless underground chambers. Not publicized becomes suppressed. Sacred sites become forbidden zones. Safety and preservation measures become evidence they're hiding something huge. A speculative show adds tense music, dramatic narration, and a question they never quite answer. Could it be that beneath this canyon lies an undiscovered city? They don't say it does. They just keep asking if it might. Meanwhile, online forums and YouTube channels recycle these questions as claims. Because we'll probably never know doesn't get clicks. They already know and won't tell you does. Scale helps the story along. If you say there's an enormous structure buried under a 10-acre city park, most people will roll their eyes. Too many eyes on it, too easy to dig, too much infrastructure. Say the same thing about a 277-mile-long canyon with sheer walls, inaccessible shelves, and entire tributaries almost never visited by the general public, and it feels less ridiculous. There's enough room on the map to hide an entire fantasy. Remoteness helps too. The inner canyon is not a casual place. To get to a lot of the more remote sections, you need permits, experience, gear, time, and often guidance from people who know that terrain intimately. Most viewers of a speculative documentary will never go there. They'll never see the specific alcove being discussed. They'll never walk that ledge or look behind that buttress. They're operating on secondhand imagery and narration. And anytime you're dealing with a place that most people will only ever experience through a screen, the screen can edit reality. Cut away the trailhead parking lot, the signs, the rangers, the hikers in fluorescent shirts, the helicopter noise. Frame only the most isolated, shadowed, echoing spaces. Talk only about what you can't see behind the wall. You've taken a complex, managed, heavily studied national park and made it look like the edge of a map marked "Here be dragons." Tourism marketing can unintentionally feed the same thing. The canyon is sold as an experience that will change you. Beyond words, beyond belief, indescribable. If a place is beyond description, then anything you say about it becomes hard to check. It lives half in reality, half in projection. Souvenir stands sell Mystery of the Canyon books next to postcards and stuffed animals. Guides tell stories that mix local history, carefully gloss tribal accounts, and a dash of spooky legend, because a little chill up the spine makes for better tips. A throwaway line, they say no one knows how deep it really goes, becomes in someone else's retelling. Even scientists admit the canyon has unknown depths they can't explain. Piece by piece, partial facts are inflated into legends. The canyon's real complexity doesn't always help. Geologists explaining deep time, missing rock records, odd erosional patterns, and ancient faulting systems sound, to a lot of ears, like they're describing magic. Seas that came and went, rivers that reversed, layers thousands of feet thick, completely gone. Archaeologists talking about scattered, fragmentary evidence of past occupation can't offer the tidy narratives people crave. They talk in probabilities ranges and at least this old tribal representatives, when they do speak publicly, often won't share details of certain stories or sites, for reasons that have nothing to do with hiding and everything to do with respect and responsibility. Put that together and you get a frustrating mix, if what you want is certainty. Scientists saying, we know a lot, but not everything. Elders saying, we know some things, but not for you. Agencies saying, you can't go there, it's closed. The easiest way to compress that, in a 30-second social clip or a lurid headline, is all or nothing framing. Either everything beneath the canyon has been mapped, scanned, cataloged, and there are no mysteries, stop asking questions, or nothing beneath the canyon is known, and anything you can imagine might be true. Both positions flatten what's really going on. The first erases the real uncertainties and the sheer difficulty of working in this terrain. The second erases the decades of careful, sometimes dangerous work that have revealed an enormous amount about what's actually under there. If you want to keep both curiosity and honesty, you have to stand in the middle space that doesn't sell as easily. You have to be okay with sentences like, we have strong evidence for X up to this depth, but beyond that, our data get thin. We know this story is important to the community that holds it, but we're not entitled to the full version. We can say what geology allows and rules out, but we can't give you a list of every cave and crevice. That middle ground doesn't kill wonder. It just shifts it. Instead of maybe there's a hidden golden city, the wonder becomes, people have been trying to read this rock and live with this chasm for thousands of years, and we're still adding pages to the story. Instead of they must be hiding something, the question becomes, what does it take practically and ethically to look under a place like this? If you can hold that kind of wonder, the kind that respects limits as part of the landscape, then you're ready to talk about what scientists still don't know, and why those gaps exist, without falling back on easy conspiracies or easy dismissals. If you talk to the people who actually study the canyon, one phrase comes up over and over again. It's one of the best studied places on Earth, and we still don't have the full picture. Start with water. Everyone agrees the Colorado River carved the main trench, but the canyon's water story doesn't stop at the obvious brown ribbon at the bottom. Under the plateau, groundwater moves through a stack of rock units that don't behave like neat, flat layers in a textbook. They've been tilted, broken, folded, and sliced for more than 1 billion years. So when you see a spring gushing out of a cliff halfway down, you're seeing the visible end of an invisible journey. Hydrologists can trace some of those roots. They inject harmless dyes into sinkholes on the Kaibab Plateau and wait to see which springs light up downstream. They measure flow rates. They test water chemistry to see how long it's been underground. But it's like trying to map a subway system when your only data are the trains that make it to the end of the line. You know there are tunnels. You know trains are moving. You don't know every branch, dead end, or bypass. In the Grand Canyon, there are giant questions that sound simple and are not. Exactly how does water travel from snowmelt on the north rim to specific springs in the inner gorge? Which fractures in ancient faults act as fast highways, and which layers are barriers? What happens deeper, below the depth of most wells and most springs, where water may be moving along structures we only see in outline? Geologists and hydrologists can sketch models. They can say probably, likely. Most of the flow seems to. They cannot yet draw a precise plumbing diagram of the entire system. Then there are the caves. Scientists know there are a lot of them. Karst limestones, fractured dolomites, and old water tables mean voids are almost guaranteed. Some are known and surveyed in detail, mapped passage by passage, measured, cataloged. Others are known only as dark openings high on a wall that almost no one can safely reach. And beyond those are caves no one has seen. Not because they're magical, not because they're being deliberately hidden, but because this is a place where a short approach might involve miles of bushwhacking, sketchy ledges, serious rope work, and then whatever waits at the entrance. On top of that, the Park Service and tribes are not eager for an arms race of first descents into every hole in the wall. Some caves are closed to protect endangered species, some to protect cultural resources, some simply because they're extremely dangerous, and rangers don't want a helicopter evacuate the 100th influencer who decided to discover something. So yes, there are unmapped caves. Yes, some likely have archaeological material or biological communities we haven't documented. Yes, there are probably chambers with features no one has written about in a journal article yet. That's normal for a landscape this size. This rough, this regulated. Unmapped cave does not automatically equal cathedral-sized city full of artifacts from a lost empire. Move from the voids to the rock itself and the uncertainties keep going, just at a different scale. Deep beneath the canyon, the oldest rocks are mashed, recrystallized, and cut by faults that have moved in different directions at different times. On a simplified diagram, you can draw clean lines and say, here's the Butte Fault, here's the Bright Angel Fault, here's where they intersect. In reality, those structures are three-dimensional, with splays and bends and secondary fractures. Some segments may extend far below the current canyon floor. Some might merge with deeper features we only glimpse through regional seismic studies. When geologists run seismic profiles, gravity surveys, or magnetotelluric soundings, they're sending signals into the crust and interpreting the echoes. Those methods can show density contrasts, big boundaries, general shapes. They don't give you a crystal clear photograph of a hidden chamber. They give you blobs, anomalies, gradients that then have to be matched with what you see at the surface. You can say there's likely a deep basin here, maybe filled with older sediments we don't see in the canyon walls. You can infer this zone of low velocity probably marks a faulted, fractured belt that could move water. What you can't ethically say, based on that kind of data, is there's a carved staircase leading to a sealed stone door right here. The gap between what the tools can show and what people want them to prove is where a lot of speculation lives. And then there are the buried landscapes. Before the Colorado cut its present course, older rivers sculpted older canyons into earlier versions of the plateau. Most of those have been partially erased, filled, or chopped through. In places, geologists can see remnants, paleovalleys filled with different sediment, ancient gravel bars perched far above the modern river, unconformities where whole packages of rock are simply gone. They can reconstruct older drainage systems in broad strokes. But the exact sequence of how many ancestral canyons existed, how they linked, precisely when the main incision switched from one route to another, that's still debated. Different datasets, different dating methods, slightly different interpretations. Again, that's normal. In big dynamic systems, the picture is always a bit fuzzy at the edges. You tighten it up with more measurements. You don't pretend fuzziness means anything goes, and that's really the line that matters. Uncertainty is real. Incomplete data is not a scandal. It's the default state of science. You never have every cave surveyed, every fracture logged, every aquifer sampled, every buried surface imaged at high resolution. What you do have are constraints. You know what kinds of voids rocks of a given type and history can hold, and what they can't. You know how much material you'd expect to see at the surface, if there really were massive artificial chambers or megastructures inside a brittle cliff. You know what signatures show up when humans build on a large scale versus when water and gravity do it over geologic time. So when someone says, scientists admit they don't know every groundwater route, therefore an underground city is totally on the table, they're jumping over a lot of missing steps. Not knowing the detailed route of a spring is like not knowing the exact path your package took between sorting centers. It doesn't mean the truck turned into a dragon halfway through the trip. The canyon holds plenty of real mysteries. There are micro-ecosystems in certain caves that haven't been described yet. There are cultural layers inside canyons that haven't been excavated and may never be by choice. There are structural relationships deep below the river that we currently see only in outline. All of that is unknown in the ordinary. work in progress sense. Those unknowns are what keep graduate students writing theses and teams coming back with better instruments. They are not proof, by themselves, of extraordinary hidden things. You can hold both thoughts at once. The Grand Canyon is not exhaustively mapped in every crevice and pore. And the evidence we do have, geologic, hydrologic, archaeological, puts tight limits on what kinds of things plausibly lie beneath. Once you see uncertainty that way, not as a blank check, not as a cover-up, but as the honest contour of our current knowledge, you can start to notice something else. In a few key places, the gaps in scientific data and the boundaries in other kinds of knowledge line up in interesting ways. If you listen carefully to what native elders say about the canyon, and then listen carefully to what scientists say when the microphones are off and the cave map PowerPoints are closed, you start hearing some quiet harmonies. The words are different. The frameworks are different. The stakes often are different, but some of the boundaries land in the same places. Take water. Long before anyone ran dye tracer tests, people living on this plateau knew which springs were dependable, which dried up in drought, which you didn't casually walk up to without announcing yourself. In many tribal traditions, certain springs are alive in a literal, person-level way. They are beings. They listen. They remember how you treat them. So you'll hear an elder say, "Don't camp there. Don't throw food scraps. Don't shout. Don't point. That spring is powerful. That place is not for you to linger." A hydrologist might stand in almost the same spot and say, "This discharge is strongly connected to a regional aquifer, highly sensitive to pumping on the plateau. It's a critical habitat for endemic species. Recreational use needs tight limits." Different language, same practical outcome. This is not casual water. This is a node in a larger system that deserves restraint. Or look at dangerous places. A lot of the stories that show up in oral tradition don't sound like Instagram captions. They're full of warnings. This side canyon is where certain beings live. You don't go there without permission. That cliff line is where someone fell, and where a pattern of falling still hangs over the place. This overhang is where a story of betrayal unfolded. It carries that weight. It's easy, from the outside, to hear that purely as superstition. Then you overlay a rockfall map, or a debris flow history, or a search and rescue incident log, and some of those bad places line up very neatly with zones that geologists label as actively unstable, flood-prone, or structurally rotten. Again, not one-to-one in every case. Oral tradition isn't a disguised hazard map, and hazard maps don't capture the moral landscape. But when a community spends generations watching how snowpack, storms, rock quality, and canyon geometry work together to produce disasters, that experience condenses into a story. "Don't go there or you'll die" is a very efficient way to encode bad combination of weak shale, undercut sandstone, and flash flood funnel. Same with caves. You'll find stories that mark some openings as doorways, thresholds between worlds, places to enter only for ceremony, only with the right preparation, or not at all. From a geologist's angle, that might be a zone where thin-bedded limestone has been honeycombed by solution cavities perched over a steep talus slope. From a biologist's angle, it might be critical bat habitat, or home to troglodytic invertebrates that exist nowhere else. From a cultural resource manager's angle, it might be a burial site, or contain fragile artifacts that can't survive a parade of curious boots. The reasons and the cosmologies differ, but the boundary is in the same place. This cavity is not just another hole in the wall. You see the same pattern with protected places. Many tribal nations treat certain cliffs, buttes, and alcoves as part of an inhabited relational world. Not scenery, relatives. That doesn't translate cleanly into important viewshed or geologic type section. But when Western archaeologists and geologists started their own surveys, they repeatedly discovered that the spots wrapped in stories often also happen to be key overlooks on migration routes, nodes where trade paths converge, benches with fertile soils and reliable access to water, ledges with perfect exposure of a contact between rock units that control groundwater movement. In other words, structurally and strategically important places in a landscape where survival depends on knowing exactly where to be and when. None of this means oral tradition and science are secretly saying the same thing in code. They're not. One is rooted in relationships, obligations, memory, and ceremony. The other in measurement, modeling, and peer review. They don't just use different words, they answer different questions. But when both systems spend hundreds of years paying extremely close attention to the same cliffs, springs, and side canyons, you would expect them to bump into some of the same landmarks. The overlap is meaningful, not because it proves one side right by the other's standards, but because it shows that reality is stubborn. Unstable slopes really do fail more often. Certain fracture networks really do focus groundwater. Some caves really are thresholds to different light, different air, different kinds of life. No metaphor required. If you only trust scientific maps, you miss layers of long-term observation that were never written in journals. If you only trust stories and refuse to look at data, you miss tools that can trace a spring back through a faulted plateau or image a buried valley under your feet. The more interesting move is to drop the myth versus science cage match entirely. Instead of asking, which one is true, ask, what is each one actually trying to describe? What does each one see clearly that the other tends to blur? That kind of comparison doesn't flatten oral history into proto-geology, and it doesn't turn geophysics into just another narrative. It treats both as serious attempts to understand a very complex place, with different methods, goals, and blind spots. In the Grand Canyon, that matters, because some of the current fights over water, over mining, over access to sacred sites, depend on how you answer a basic question. What kind of thing is this landscape? A resource, a relative, a laboratory, a temple, a hazard zone, a homeland? Depending on who you ask, the canyon is all of those. And when multiple knowledge systems quietly agree that certain parts of it are powerful, fragile, or off limits, that's a signal worth listening to before you go looking for what else lies beneath. So after all of this, if you strip away the clickbait and the grainy YouTube thumbnails, what actually lies beneath the Grand Canyon? Start with the part that is least mysterious and most humbling. Under the familiar red and orange walls, under the temples and buttes with postcard names, there's a foundation of rock that is almost unimaginably old. The basement, those dark Vishnu schist and Zoroaster granite rocks you see at river level in the inner gorge. They're not just old in a casual sense. They're more than 1.5 billion years old. In places, close to 2 billion, and they don't just stop where the canyon walls stop. Drilling, regional geophysics, and mapping around the edges of the plateau all point to the same thing. A huge, crumpled, ancient crustal block continues down and out under the canyon, stitched together from even older fragments. So beneath the canyon you have deep, metamorphosed basement rock, cut by faults that have slipped multiple times over hundreds of millions of years. Overlain, in places, by buried valleys and ancient erosion surfaces we only see in cross-section. Stacked on top of all of that, you have the younger sedimentary layers, dipping and stepping in ways that create hidden pockets, lenses, and ledges. That's the skeleton. Inside that skeleton, things get more complicated. Those faults and fractures aren't just lines on a map. They're pathways, they're how water moves, they're how caves start. They're how small voids can sometimes become big ones. Everything we know from dye tracing, groundwater chemistry, and cave mapping says there are extensive aquifers moving through the plateau and under parts of the canyon, mostly in specific limestone and sandstone units. They're not giant underground lakes in the sci-fi sense. They're more like enormous saturated sponges where water threads through fractures, bedding planes, and solution in large channels. In some zones, that slow seepage widens into caves and conduits. In others, it just darkens and weakens the rock until a slab fails and becomes part of a rockfall. So one honest answer to what lies beneath the Grand Canyon is ancient crystalline rock, thick stacks of sedimentary layers, faults and fracture networks, pressurized and unpressurized aquifers, a lot of small voids, some medium ones, a scattering of large caves, plus a buried landscape of older canyons and hills that were carved long before the modern river, now entombed in younger rock. All of that is very well supported: drill cores, seismic lines, gravity data, isotope studies, mapped caves, direct observation. Where the evidence thins out is at the scale and the specifics. Could there be a truly massive undiscovered chamber under some remote side canyon? Geologically, it's not impossible. You can get very large voids where thick, soluble limestone sits at the right depth relative to the water table, and where there's a long, stable period for dissolution to outpace collapse. We see that in other karst regions of the world. But here's the constraint. Big, empty spaces in rock change how that rock behaves. They leave signatures, overlying beds sag, fracture patterns change. Water chemistry and spring behavior reflect the plumbing. So far, the combined weight of geologic mapping, remote sensing, and on-the-ground exploration points to lots of caves, lots of smaller voids, and no evidence for continent-shaking hidden cities. Which brings us back to the legends. Why do stories about Egyptian tunnels, sealed vaults, and bottomless caverns hang on so stubbornly? Partly because the canyon is genuinely undermapped in 3 dimensions. There are still blank spots. That's catnip for the imagination. Partly because official secrecy about some things, burial sites, sensitive ecological zones, hazardous caves, blurs into blanket suspicion about everything. And partly because maybe there's a lost civilization under there is a more glamorous story than a billion years of complex groundwater rock interaction produced a messy network of solution features we're still trying to fully understand. The durable part of those stories isn't the claim that there's a specific Pharaoh-era vault behind a specific door. It's the sense that there are thresholds in this landscape, places where the surface is not the whole story, places you are not entitled to see just because you're curious. That's where native warnings slide back into view. When elders say there are things beneath the canyon that are not for casual eyes, you can hear that on several layers at once. On one level, it's about beings, stories, and spirits that are part of a living cosmology. On another, it's about practical danger, loose slopes, bad air, unstable ceilings, confined spaces that can kill you faster than you can explain your theory on camera. On another, it's about respect and limits, burial sites, ceremonial spaces, and water sources that are not props for adventure content or proof of concept for someone's pet conspiracy. So what lies beneath the Grand Canyon? A very old, very complicated piece of Earth's crust. Water paths that tie distant snowfields to tiny seeps. Caves that shelter bats, artifacts, bones, and ecosystems that never see the sun. Unmapped fractures and voids we don't yet have the tools or time to resolve in detail. Stories, warnings, and obligations that treat those hidden spaces as part of a larger, inhabited world. The canyon is more explainable than the wildest legends suggest. The big strokes of its structure, its water, its rock history are not a mystery. We can model them, test them, argue about details, and still land in roughly the same place. At the same time, it's more mysterious than the tidiest diagrams imply. There are still unknowns under those cliffs, still springs whose exact sources we're guessing at, still caves we haven't crawled into, and probably never should. Humility in a place like this isn't just a moral posture, it's a practical one. It means taking the data seriously without pretending the dataset is finished. It means hearing the warnings and stories without turning every story into a literal map. It means accepting that some parts of the canyon above and below will remain partly hidden, not because someone in an office is suppressing the truth, but because that's how complex landscapes and human relationships to them actually work. In that sense, what lies beneath the Grand Canyon is exactly what you'd expect from a place this deep in both rock and meaning. Enough evidence to know we're not in the dark. Enough mystery to remind us we're not in charge.